introduction. Apologies for the delay. I would like to acknowledge I have many members of my family here, but I'll mention alumni of this college. Alice, Florence, and Sheila Baingana. They are all alumni of this college. So the title of my thesis or my research is Influence of Helicobacter pylori infection during pregnancy on the pregnancy anemia intervention package in Uganda. And it was more of a case study carried out at Kawempe Health Centre. So that is the outline I'm going to follow. It's actually two studies, two independent studies, so I'll present each one on its own. There are some definitions that I'll be using throughout, so just to go through very quickly. Hemoglobin, anemia in pregnancy is defined in this study as hemoglobin less than 11 grams per deciliter. That is the World Health Organization. In other countries, they use different cutoffs, but this is what we use here. Iron deficiency is ferritin, less than 12 micrograms per liter. Our serum transferrin receptor, greater than 8.3 milligrams per liter. For serum ferritin, it's standardized, so whichever test or method you use, it's the same. For serum transferrin receptor, it depends on the method that is used. So iron deficiency anemia is a combination of the two. There has to be anemia and there has to be iron deficiency. Also very important in this study is the acute phase response or infection inflammation, which is C-reactive protein greater than 5 milligrams per liter, or alpha-1 acid glycoprotein greater than 1 grams per liter. So I'll be using these a lot throughout. So anemia is a huge problem globally. It is worse for young children and for pregnant women. As you can see from the map, it doesn't leave out any country as such. Anemia in pregnancy and in young children is a problem all over the world. And Uganda is there. And in Uganda, around the time I conceptualized this study, the prevalence of anemia in pregnancy was 64%. Currently it is 38%. So it is still a public health problem. There are many factors that contribute to it: malaria, hookworm, poor dietary intake, and other infections. So I looked at Helicobacter pylori as one of the contributing factors to anemia in pregnancy. At the time I conceptualized this study, there was not very much information on the prevalence of H. pylori in Uganda. So those were the studies that were available, and as you can see, they were in select people. So people with cancer, people with gastritis, but not from the general population, apart from the last two studies which were in children. So there was a gap there concerning the prevalence of Helicobacter pylori in Uganda. But generally speaking, in developing countries, the prevalence is very high. It's a bacteria that affects almost everyone. We have migrated with it. Eons ago, when people migrated out of Africa, they moved along with it. So it's been with us a very long time. But in developed countries, the prevalence is going down. It is still high in developing countries, where you may find even 100% of adults have Helicobacter pylori. So it's a bacteria that infects or that lives in the stomach, and it's associated with gastritis, with peptic ulcer disease, and with gastric cancer. So why Helicobacter pylori and iron deficiency and anemia? At that time, there were some studies, mostly in adolescents and in children, that showed that Helicobacter pylori had a role to play in iron deficiency and anemia. They were fairly small studies, but they were quite compelling. So I thought that if Helicobacter pylori can have this effect in adolescents and children, what about pregnant women who are even more vulnerable to anemia? And so that was the basis for my study. And at that time, there was very little that had been done in pregnancy in terms of Helicobacter pylori and anemia and iron deficiency. So that was the background for my study. So anemia is a public health problem, and it remains a major problem in pregnancy in Uganda and other countries in the region. And we know the contribution of malaria to anemia in pregnancy. We know the contribution of hookworm. We know the contribution of HIV. But we do not know, there's a residual part of anemia that, these infections or conditions do not answer. So there's still anemia in pregnancy that is not addressed by interventions in malaria, hookworm, and so on. And we've not, at that time, we had not described comprehensively the etiology of anemia in pregnancy. Secondly, we also still had gaps in terms of the efficacy of iron supplementation in pregnancy. So mothers were getting iron supplements, but we are not seeing the huge impact that we would expect from the iron supplementation. So that was the problem or the research question I was trying to address. What is the contribution of these different factors, and how does Helicobacter pylori affect the iron supplementation in pregnancy? So my general objective was to identify factors that limit the efficacy of the intervention package for anemia in pregnancy, that is iron folic acid, malaria, and hookworm control for anemia in pregnancy in Uganda. So this is a Ministry of Health policy for anemia in pregnancy. Specifically, I first wanted to determine the prevalence of H. pylori infection in pregnant women in Uganda, because there was no information and I needed that as a background for the second study. My second objective was to determine the risk of anemia in pregnancy associated with H. pylori infection. Our secondary objective was to determine the contribution of the different factors, iron deficiency, malaria, hookworm, and inflammation to anemia in pregnancy. Then my third objective was to determine the impact of H. pylori infection on the efficacy of the intervention package for anemia in pregnancy in Uganda. So the significance of this research is that knowing that the contribution of the different causes of anemia in pregnancy can support or can inform the strategies to deal with these causes of anemia. And also, there's a global nutrition target of 50% reduction in anemia that was established, 50% reduction by 2025. And one of the actions is to improve identification, measurement, and understanding of anemia. So this study contributes to that. If we understand the causes of anemia in pregnancy or in women of reproductive age, then we can deal with those causes and reduce the prevalence of anemia. So this was my conceptual framework. It is also a way of summarizing the literature review. So we have different causes of iron deficiency and anemia in pregnancy. You have poor dietary intake, especially in our setting because our diet is mainly from plant sources. The iron in the plant sources is not very well absorbed. So we do have inadequate dietary intake as one of the causes of iron deficiency and therefore anemia in pregnancy. Then hookworm infestation and malaria, those have been very well studied, and that's why they are part of the intervention. H. pylori infection, this was the major question I was looking at. Then other infections, syphilis, HIV, and any other infection that is reflected by elevated C-reactive protein and alpha-1 acid glycoprotein. So here I've underlined HIV because in this study I was not considering HIV, as we shall see later. So all of these could contribute to iron deficiency, and these could contribute to anemia of chronic disease, which lead to anemia in pregnancy, which has several outcomes, including low birth weight. So in this study, I was not looking at birth weight, and I was not looking at these factors down here, but they are presented here for completeness. They can also affect the anemia control package, pregnancy anemia control package, but they were not the focus of my study. So the first study was looking at the prevalence of Helicobacter pylori infection in pregnant women in Uganda to provide a background for the second study, the main study. So the target was to have 500 subjects, and I looked at 4 health facilities in each of 4 districts. This work was supported by innovations at Makerere. So these 4 districts, Apache, Mbale, Mbarara, and Rakai, were within the innovations at Makerere focus districts. Then I also looked at Kawempe Health Centre in Kampala. So on that day I collected data. Every woman who came for ANC was approached, and those who consented to participate were enrolled. I had a questionnaire administered for social demographic data and household characteristics. Stool samples were collected in new and used sample bottles and transported in a full box with frozen gel packs to the department at the main campus where the stool was analyzed using the H. pylori stool antigen test. Samples were analyzed on the same day or were stored in a refrigerator or for at most 7 days or were frozen 20 minus 20 pending analysis. So I did not keep these samples for more than 48 hours or 7 days before analysis. And I had approval from the then Faculty of Medicine Research and Ethics Committee and registered the study with the National Council of Science and Technology. So those are the districts and the health facilities that I went to for in each district plus Kawempe Health Centre. I used principal components analysis to generate a socioeconomic score, cross-tabulation for frequencies and proportions, chi-square to measure associations between H. pylori infection and background characteristics, and logistic regression, and I used SPSS 13. So the results are very, very summarized. This is what I found in terms of the prevalence of Helicobacter pylori. Overall, it was 45.4, which was a bit lower than what the literature indicated. And this was mainly due to the very low prevalence. This is 18.2 in the samples from Kampala District. So the highest prevalence was at Kawempe Health Centre, which would be expected, being a health facility that serves a low-income and highly congested area. So the bars, these bars represent the confidence intervals. So definitely the prevalence in a patch was very different, significantly different from the prevalence in the other areas. So like I said, the results for this particular study are very summarized. I won't present all the descriptives and background characteristics, but this was the final model of the factors associated with H. pylori infection. So firstly, when I used a patch as a reference, in the other areas, the odds of H. pylori infection were almost 6 times the odds in a patch. The odds of H. pylori infection were lower in rural areas compared to urban areas. Odds were lower for women who had some education, primary and above, compared to those who did not have any. And the odds were higher for women who collected water from, I would say, open sources, compared to those who had their own taps within their compounds or homesteads. So a public tap had higher odds, but this was still lower than the open sources of water. So what is the meaning in these findings? Firstly, the significant variation that I found was totally unexpected, because the literature said over and over that the prevalence was higher in developing countries, especially Africa. So it was very unexpected to find a very low prevalence in a patch. But it was not unprecedented. Some previous studies had found a low prevalence in other places. In Pemba, in Zanzibar, the prevalence was 17.5, and women recruited at health facilities along the major highway, so in the more sort of urban places, had higher odds of H. pylori as compared to the women who were recruited further away from the main road. Then there were studies also in the pygmies, the Baka pygmies in the Cameroon. The prevalence of H. pylori is much lower, 20.8 or 21%, compared to the non-Baka, where the prevalence is 80%. And also in ethnic Malays. More recently, in a study that was done in Amuria district, none of the women had H. pylori, but this was based on a slightly different test. The prevalence of H. pylori there was 0. None of the women had H. pylori. So it is not so unprecedented that I found a very low prevalence in a patch. And just for comparison, in 2016, the prevalence at Kawempe Health Centre, a different study, was 53%. So the findings of this first study suggest that there could be a racial cohort, in inverted commas, phenomenon. And the distribution, this variation in the distribution offers an opportunity to study transmission dynamics. The use of rivers, lakes, and streams, based on the findings of this study, are a risk factor for H. pylori infection, and this suggests waterborne transmission. So we need to enhance our efforts in environmental health in communities and at the household level. Then having no formal education, as we saw in the results, was positively associated with H. pylori infection, and this may mediate the role of the water source. If people are not formally educated, they may not appreciate the need, for example, to boil water before using it, or to share water places with, as toilets or that kind of thing. So those are the conclusions I drew from this first study, and it was published and also presented at a conference. So the second study, which is the main study, looked at the influence of H. pylori infection on the pregnancy anemia intervention package. This study was done at Kawempe Health Centre. It was a longitudinal study. Kawempe division has a population, or had, of almost 300,000, which is about a fifth of the population in Kampala. And in some of the most densely populated areas of Kampala are in Kawempe division. So the design, HIV negative women with and without H. pylori infection in their first or second pregnancy were recruited during the first trimester and followed until delivery. They were assessed at baseline, and we shall see what that involved. And iron and folic acid supplements were provided on a monthly basis from recruitment until the last contact before delivery. Follow-up assessments were during the second and third trimesters, and mebendazole and Fansida were provided according to the national anemia policy. And the study was approved and registered with National Council. Inclusion criteria: the women did not have severe anemia. Gestational age had to be less than 16 weeks. They had to be in their first or second pregnancy, and they had to be HIV negative. And exclusion criteria were any pregnancy-related complications that were identified during baseline assessment or during the course of the study. Those are some of the images. This was before the hospital was built. Actually, as I was completing the study, they were kind of chasing us away because the hospital was going to be built. So those are the factors that I included or considered in calculating the sample size. And so I needed to screen around 188 women and to recruit 68 per group. These are the variables that were included in the study: socioeconomic status, education level, ethnicity, age, dietary intake of iron, used a food frequency questionnaire, syphilis, H. pylori status, malaria and helminth infection, iron deficiency using, as I mentioned before, soluble transferrin receptor and serum ferritin. So these, and then infection and inflammation, CRP and AGP. So these four biomarkers were measured by myself in the lab in the Department of Biochemistry. Then hepcidin, at that time, we did not have well-validated kits for measuring hepcidin. So I had to transfer the samples to the Netherlands, where they used weak cut ion exchange time of flight mass spectroscopy to measure the hepcidin. The dependent variables were hemoglobin and, of course, anemia. I used principal components analysis again for household socioeconomic score and also to get a score and index for dietary intake of iron. Then adequate iron folic acid supplementation was taken as more than 23 tablets or the tablets taken for more than 23 days at first follow-up and 45 days at second follow-up. Ferritin had to be transformed. It was not normally distributed. And I also had to adjust ferritin for the effect of the acute phase response. It's a positive acute response protein. Logistic regression for risk factors for anemia in pregnancy at baseline, and then for the longitudinal study, linear mixed model fitted for hemoglobin and weighted general estimating equations for anemia versus no anemia. So the results, first the study profile. I had 151 women enrolled. At first follow-up, I had 76, so about half did not return. And then I had 52 at the second follow-up. I compared, I'm not going to present those results here, but I compared the women who were lost to follow-up and those who returned based on the baseline assessment, and they were not different. So those who were lost to follow-up did not bias the sample that continued in the study. So I'm not again going to present all the descriptive results, the descriptive data, just perhaps this one. So at baseline, 70% of the women were H. pylori positive, follow-up 1, 72, follow-up 2 were 87, but this does not reflect new infections. It reflects that some of the women who did not return, the ones who were negative. But when you look at the proportions and the confidence intervals, they are not different. 2.7% were positive for syphilis at baseline. I did not do syphilis at the follow-up. 5.3 had malaria parasites at baseline, and this reduced 1.3, 2.1. 5.3 had stool parasites at baseline, and the same at follow-up 1. And then iron and folic acid supplementation at baseline, of course, they had not yet started. At follow-up 1, it was 77.6%, and it went down to about 60%. So this summarizes or presents the distribution of anemia, which is what I was interested in, by maternal characteristics. So firstly, here at the bottom, you have the number that were H. pylori negative, positive. So malaria negative, you had 8 positive, and so on. So here, the positive are the ones who are iron deficient, and these are the ones who have raised AGP or CRP, stool parasites. So you can see almost across the board that the prevalence of anemia is higher amongst those who are H. pylori positive, but not significantly different. It is higher amongst those who had malaria, and it was significantly different. Higher amongst those who had stool parasites. Higher amongst those who had raised AGP or CRP inflammation or infection. Higher amongst those who had iron deficiency based on serum transferrin receptor and based on ferritin. So So this is breaking down the previous slide a little bit with a bigger focus on anemia and iron deficiency. So in this bar chart, I looked at the two indicators that I was using for iron deficiency, transferrin receptor and ferritin, amongst the women with anemia and those without anemia, and this is at baseline. And what stands out here is that amongst the women with anemia, you have this group here that do not have iron deficiency. So they have anemia, but they do not have iron deficiency, which means that the anemia is caused by something else other than iron deficiency. Secondly, they have raised C-reactive protein and alpha-1 acid glycoprotein, so they're in a state of inflammation and without anemia. And this state is referred to as anemia of chronic disease, or more recently the term has changed to anemia of inflammation. So there's no iron deficiency, but there's anemia, and CRP and AGP are raised. So looking at this group in a bit more detail here, so the women who had anemia were 44. 12 of these had iron deficiency anemia, but the majority had anemia without iron deficiency. And of these, 24 had raised CRP, AGP, so these ones. And that is the anemia of inflammation. And what you see, it is the biggest proportion of anemia is anemia of inflammation, anemia without iron deficiency. So this is the logistic regression for anemia at baseline, of the factors that are associated with anemia at baseline. I had to include H. pylori status here because it was the major independent factor that I was looking at, but as you can see, it is not significant. Malaria was, stool parasites almost, CRP status was not, but iron status based on serum transferrin receptor was. So at baseline, the two major factors that were associated with anemia were iron deficiency and malaria, as to the CRP was not. So that work was published, and during the review, the reviewer suggested that I look at population attributable risk instead of just looking only at the logistic regression. So what population attributable risk helps with is trying to estimate that proportion of anemia that will be removed if a particular factor is dealt with. So if we deal with malaria, how much of the anemia will be removed? So this First slide here has the results that I presented on the previous slide. And this is the population attributable risk. And you can see the largest population attributable risk is the raised CRP. So if we were able to deal with the raised CRP, we would remove 41 or almost 42% of anemia in pregnancy in this sample, or anemia in pregnancy. Malaria would be 12%, and iron deficiency 13%. So the largest contributor to anemia in pregnancy at baseline, this population was 42, was raised CRP AGP, which is quite important, as we shall see. So H. pylori was not associated with anemia in pregnancy at baseline. The first study that described this relationship was a retrospective study. So women had given birth, they were tested for H. pylori, and then they went back in their antenatal care records to look at their hemoglobin levels. And you can see that mean hemoglobin was lower among women with H. pylori by 0.25 grams per deciliter, but the confidence interval, especially this lower limit or upper limit, is very close to zero. In a different study in Zanzibar, the odds of H. pylori among pregnant women with severe anemia this time was 8-fold. And they were also consuming a diet low in key iron. So here the inclusion criteria was a bit different. We're looking at severe anemia, which I did not look at. I excluded women with severe anemia. And so it suggests that it's important to consider diet and relative causes, other causes of anemia like malaria and so on. And also the severity of anemia. Then another factor that could be considered is the virulence factors, cytotoxin-associated gene A, or CAG-A, and vacuolating cytotoxin, VAC-A, which are involved in iron acquisition from host cells. And these are polymorphic, which means that they will not be the same or they are not expressed in the same way in different populations, and maybe in some populations their aggressiveness at acquiring iron might be different from other populations. Malaria parasites and iron deficiency were associated with anemia, even though, and I keep emphasizing this, over 2/3 of the women did not have iron deficiency at baseline. So they are still important to consider, but there's still that factor of infection, inflammation that has to be considered. So infection and inflammation is a major consideration in anemia in pregnancy. like I've already said, over 2/3 of mothers with anemia did not have iron deficiency, and 2/3 of mothers with anemia had raised CRP and AGP. And 75% of those who had anemia without iron deficiency had raised CRP, AGP, that is anemia of chronic disease or anemia of inflammation. And as we saw, inflammation had the highest population attributable risk for anemia. So the literature shows that CRP increases physiologically in pregnancy, but the level that I found in this study was, beyond that physiological increase in CRP. The literature also shows that there's association with race or ethnicity with black people, or Africans, or these studies were done in the US, so African Americans have higher CRP. So those are some of the things that need to be investigated further in our context. So part of this study, the baseline, was presented at the International Congress of Nutrition in 2013. This one focused on hepcidin and inflammation. I have not said very much about hepcidin. The reason why will come later. So the third objective, or the second objective for this particular study, was longitudinal. So I started by looking at the anemia and hemoglobin across the 3 time points. So in this first graph here, you have mean hemoglobin. Baseline, it was fairly high, and it reduced across the 3 time points. And like I presented in the first bar chart, in the women with H. pylori, the prevalence of anemia was higher, which would suggest that the mean hemoglobin was lower, which is reflected here. So these are the women who had H. pylori, and these are the H. pylori negative. So there was a difference, but the difference, if you look at this scale, is a bit small. The other thing is that across the 3 time points, hemoglobin tended to reduce. Then with anemia, the prevalence increased slightly, and you had a higher prevalence amongst the women with H. pylori compared to those without. So this is trying to explore the supplementation relative to the anemia. And basically what we see here is that there was no association or relationship between those who had adequate iron supplementation and those who did not. Those who had adequate and those who did not. And also when we break it down by H. pylori status. So the final random effects model fitted for hemoglobin, that is looking at the change in hemoglobin over time and taking into account the different risk factors. Helicobacter pylori was not significant, or it did not affect hemoglobin significantly. Malaria did, and there was a reduction in hemoglobin amongst those with malaria. Being or not being iron deficient based on serum transferrin receptor, there was a slight increase in hemoglobin, and there was no effect of the supplementation taking into account H. pylori status. And then for anemia, we get similar results. Again, malaria parasites and iron status. So the prevalence of the anemia increased amongst those with malaria, and the prevalence. And the prevalence amongst those who are not iron deficient reduced. So quickly, the reduction in mean hemoglobin and increase in percent in anemia were not significant on their own, but only when you look at the particular risk factors of malaria and iron deficiency. The literature shows that the change in hemoglobin over time depends on, firstly, the level of anemia or the level of hemoglobin at baseline, and also on the supplementation. So women who are anemic at baseline tend to benefit from supplementation and over pregnancy, and women who are not anemic at baseline might experience some reduction in hemoglobin over pregnancy. That is, the key things these studies have demonstrated. And so if you find that the difference that you get might not necessarily lead you to a huge decline in hemoglobin amongst those who did not get iron folic acid supplementation, as opposed to a larger increase among those who do. Similar to what was found at baseline, H. pylori was not a predictor of the development of anemia and did not influence the effect of iron folic acid on hemoglobin during pregnancy. The key thing from here is the effect. What is the effect of anemia status? Because other studies have found that if the women have severe anemia, then H. pylori infection has an effect. And then, as we've already seen, malaria and iron deficiency were very important in the longitudinal study. So these are limitations, some limitations of the study. There was the missing data, but that is not unprecedented in studies in pregnancy. Iron intake used a qualitative assessment, the food frequency questionnaire. Hepcidin is a master regulator of iron metabolism, and it was very important to measure it in this study, and it would have been the first data of hepcidin in pregnancy here. However, during shipment, the samples delayed led to thawing of the samples. So in the end, we were not sure, that is myself, the supervisors, but also the people who analyzed the samples were not sure that some of the hepcidin had degraded. So although we found that the hepcidin followed patterns that have been reported in other studies, we still can't be 100% sure. So H. pylori, in conclusion, was not associated with mild and moderate anemia, and it did not influence the response to the maternal anemia control package. We still need to put a lot of effort in preventing and controlling malaria during pregnancy. Even if the prevalence is low, it is not something that we should stop doing. We need to address iron deficiency, yes, but the majority of the anemia was not due to iron deficiency. And this raises some issues about targeting of iron supplementation. We need some CRP reference levels. We do not have those. And because it increases during pregnancy, we need to be able to describe the CRP in pregnancy. It increases physiologically in pregnancy, so we need to describe that separate from an increase due to infection or inflammation, and then understand how that can affect anemia and iron status. Then we need further studies, and I think the number of studies on hepcidin in pregnancy are increasing. So that is useful information, but we need more of those studies in our context. So the last slide is acknowledgements. I acknowledge the funders, innovations@makerere.com and the Nutrition Research Foundation. I acknowledge my supervisors, Professor Inyaru and Dr. Lena Davidson, the mothers who participated, the district directors of health services who gave me permission to work in their districts, the in charges of the health facilities, ANC service providers, the lab team at Kawempe Health Centre. I acknowledge Pros, she's here. She provided research assistance. I've had a lot of administrative support, especially in the last year or so, from Dr. Chambade, Dr. Vuzi, Dr. Chiuwa, from Brenda Okech, she was here, Mr. Fred Juko, I don't know how many miles he has walked, Angela, and Peace. There are some people whose only way of greeting me was to say, how far have you gone? One of them is here, Dr. Haumba, and Professor Eri Katavira. And the third one is Professor Ntale, the Department of Chemistry. And the reason he did that is we once met in a patch. We were both there collecting data. I also acknowledge my colleagues Department of Biochemistry and Sports Science, and my family and friends who are well represented here. Thank you.